Implicit differentiation. Find the derivative of y with respect to x by implicit differentiation. So what that means is that we're going to have to treat y as a function of x. Now, whenever we're doing this, every time that you're taking the derivative of y, you're going to treat it as a chain rule. So let's start taking the derivative of each side. But to do that, I believe if we raise this guy as a product of as a power, so that will be 2 times x to the 1/2 plus y to the 1/2 equal to 3. Now I will apply the derivative in each side with respect to x, d over dx of all of these, and this one d over dx. So we're taking the derivative with respect to x in each side. Now we're using the property of derivative, so if it's a sum here, it's pretty much you're taking the derivative of each of the addends. So the derivative of this guy and the derivative of this guy here. So at this stage, we're very familiar with our product, with our differentiation rules. So what I'm going to do here, I'm going to take this 1/2 on front multiplying, and then I'm going to subtract the power minus 1, so it's going to be negative 1/2. I will do the same technique here, 1/2, and then y to the negative 1/2. But here, this is the hardest part in implicit differentiation. So you're taking the derivative of y, so it will be 1/2 times y to the negative 1/2 times the derivative of the inside, so it will be times the derivative of y, equal to derivative of 3, derivative of a constant is always 0. Now let's start to isolate for y prime. However, look at this part here, they eliminate, so you're pretty much left with x to the negative 1/2 plus 1/2 y to the negative 1/2 y prime equals to 0. We need to isolate for this guy, we need to leave this guy by itself. So I'm going to subtract x to the negative 1/2 each side. So in other words, I will get 1/2 y to the negative 1/2 times y prime equal to negative x to the negative 1/2. Now multiplying each side by the reciprocal by 2 over y to the negative 1/2, this guy here times 2 over y to the negative 1/2, what I'm going to get is I'm going to get this guy by itself. So this guy cancel out, cancel out, cancel out. Y prime is by itself equal to, well, what I'm going to get here is actually negative 2x to the negative 1/2 over y to the negative 1/2. However, we cannot leave negative exponents, so I believe we could also reduce this guy here. So I'm just gonna do it here. So this guy here will be actually negative 2, and this guy here is gonna go on top as a positive exponent, and this guy here is gonna go as a positive exponent as well. So, but now this 1/2 is actually the square root. Therefore, in other words, I'm going to write here, therefore, y prime is equal to negative 2, and then we'll have a square root of y over a square root of x. So that's going to be your answer. Now let's do problem number 2. So let's take the derivative here. So we have to apply the derivative in each side. So what I'm going to do here is I'm going to take the derivative here. So I'm going to differentiate this guy with respect to x. With respect to x, that's the hardest part, okay? We need to understand that we have to differentiate with respect to x. Now, but whenever I'm taking the derivative here, I'm going to have to use the product rule, which says that it's going to be the derivative of the first term, right? Times the second function plus the derivative, the first function times the derivative of the second one here. So I'm going to put a prime there. So times the derivative of y here equal to the derivative of y, which is going to be y prime, minus the derivative of 1 is 0. I'm just doing everything at once. So however, here the derivative of x with respect to x is just 1. So pretty much 1 times e to the y is just e to the y plus x. But here's the hardest part here, okay? So this part here, you're going to have to use a product rule. So the derivative of e to the y is e to the y. And the derivative of the power here is going to be y prime equal to, well, y prime is just y prime here. So remember that you have to isolate for y prime. In order to do that, I'm going to have to move this guy here to the other side. It's just pretty much you're subtracting the same quantity. So you will have e to the y is equal to y prime minus x e to the y prime. Now the reason why we do that, so you can factor this guy here. So you will get 1 minus x to the e to the y. And this side you had the e to the y. Now just to leave the y prime by itself, you just have to divide that. So I'm gonna have to divide by 1 minus x e to the y. That's actually that y prime. That's what we were asked to do. So therefore this should be my my differentiation of dy over dx. Remember that y prime is actually dy over dx. So let's do problem number 3. Use implicit differentiation to find an equation of the tangent line and the normal line to the curve at the point 2, 1. Recall that anytime that you're being asked to find the equation of the line, you need the slope and the point. We do have the point, but we do not have the slope of the tangent line. To find the slope of the tangent line, you pretty much need to find y prime. So the very first step here will be to find y prime. So in order to find y prime, what we need to do here, I'm going to have to use the implicit differentiation. So I'm going to take dx of each side. So, and then I'm going to have here dx d over dx. So we will get, well, I actually got to take the derivative of this guy of individual, because I'm going to have to pretty much take the derivative of x squared plus the derivative of 4xy plus the derivative of y squared. So we're differentiating with respect to x, so we're gonna get 2x plus 4 times, okay, this one here, be careful, okay, this is the product rule. So the product rule will be 1 times y plus x times y prime plus the next one here, this y squared is actually going to use the chain rule. So it's going to be 2y times y prime equals to derivative of 13 should be 0. Now let's, well, also 1 times y is going to be like y, so pretty much don't need this anymore. So I'm going to have 2x plus 4y plus 4xy prime plus 2y y prime equals to 0. Something really cool about calculus right now is that, see, like all of these here divisible of 2. If I divide each of them by 2, I pretty much getting rid of that 2. So I'm gonna have x plus 2y plus 2xy prime plus y prime equals to 0. So let's isolate for y prime. In other words, let's leave the one that has y prime in one side. 2x y prime plus y prime equal to negative x negative 2y. Now here we're going to factor the y prime. Once you factor y prime, you got 2x plus y equals to, well, I'm going to factor the negative 1 here. So x plus 2y. Then I'm going to have to divide by the same quantity there. So you have negative 1 is equal to x plus 2y over what are we going to have here? 2x plus y. So, but this is the derivative at any point. This is at any point. So if this is a derivative at any point, I mean the slope of at any point, this is the slope of the tangent line at any point. So if this is the slope of the tangent line at any point, we're being specific. They want us to do derivative the equation of the line at the point 2 comma 1. So at the point 2 comma 1, this is x and this is y. Let's find our slope there. Y prime is going to be what? So I'm going to put y prime, and here it's going to be 2 comma 1. So we're going to get -1 times 2 plus 2 times 1 over, here we're going to have 2 times 2 plus 1. So what we're going to have here is -4 over 5. So this is going to be the slope of the tangent line at the given point 2 comma 1. So now to find the tangent line, so I'm going to here the equation of the tangent line using our formulas. You can either use the formula that you used to use in algebra, like y minus y1 equals to mx minus x1. You can use that, or you can use the one in calculus that we use, which slope, the m is going to be changed for the y prime. You can use any formula as you wish. So I particularly prefer just using this one here, because this is the one that we were so familiar in during the algebra courses. So I'm going to have this y minus y1 in this case here. Just going to remind that this is a 2.2 comma 1 with a slope -4/5. Okay, so it's going to be y minus 1 equals to -4/5 parentheses x minus 2. So let's isolate for y here. I'm going to distribute this guy here. So it's going to be y minus 1 equals to -4/5 x plus 8 over 5. Now I'm going to add 1 each side. So if I'm adding 1 each side, I'm going to do plus 1 here. But plus 1 is like having plus 5 over 5. So this will be y equal to -4/5 x plus 13 over 5. So this is going to be your equation of the tangent line. Now let's do the equation for the normal line. The normal line, recall that the normal line is pretty much the perpendicular line, so whose slope is going to be the negative reciprocal of the tangent, which is going to be 5 over 4, and at the same given point there. So I'm going to use my formula. So it's going to be y minus 1 equals to 5/4 x minus 2. Now I'm going to distribute these 5/4 to each of them, and we're going to get 5/4 of x minus 10 over 4. I think I'm going to be able to reduce there. Okay, so if you reduce this guy here, it's pretty much 5/2. All right, but remember that you also add in plus 1 here. So if you're adding plus 1, I can just add plus 2 2's here. So y is going to be equals to 5/4 of x. -5 plus 2 is going to be -3 over 2. So this is going to be your equation of the normal line. Now let's do problem number 4. So in problem number 4, they're asking you to find the second derivative of x to the 6 plus y to the 6 equals to 1. So what are we going to do here? We're pretty much going to use this explicitly again. So implicitly. So we're going to take the derivative of them each side. So if I take the derivative here, I'm going to rewrite it. So d over dx of this x to the 6. You're pretty much taking the derivative for each of them. So just going to rewrite it like this. All right, equal to derivative of this guy here as well. So the derivative of x with respect to x, that will be 6x to the fifth power plus, here we're going to use a chain rule here, so it's going to be 6y to the fifth times y prime equal to, that will be 0. So isolating for y prime, we're going to have 6y to the fifth y prime equals to negative 6x to the fifth power. Now this guy goes away, and you can just divide by y to the fifth each side, and you pretty much get that y prime is equal to negative x to the fifth over y to the fifth power. So let's keep this in mind, because we're asked for the second derivative, so we're not asked for the first derivative. So what I'm going to use here, I'm going to take the derivative again of each side. So I'm going to take d of dx of this guy here equal to the derivative of this guy again. But in this case here, well, this negative one, this negative, I can just put it on front. So I'm going to have the double derivative is equal to negative 1, right? Times, well, here I'm going to have a quotient rule. I'm going to write here quotient rule. So the quotient rule is a little bit complicated, so I'm going to put a bracket here. I'm going to take the derivative of the first one, which is going to be 5, so that should be 5 x to the 4 minus, well, times y to the 6. So I believe I forgot to do that part here, so give me a minute. I'm going to erase this part here. Okay, so we're going to have 5x to the 4 times the second function minus the first function times the derivative of this guy, which is actually 5y to the 4 power times y prime. We're using there a chain rule. All of this is being divided by the bottom part squared, so it will be y to the 10. All right, so we're gonna have to use this one here. I'm gonna write it y double prime is equals to negative 1 times all of these guys here. But now see, this is 5x to the 4 y to the fifth minus 5x to the fifth y to the 4 times y prime. But what is y prime? Y prime, actually I put it here in a cloud here. Y prime is actually negative, so I'm going to put here negative x to the fifth over y to the fifth. So, and all of this is over y to the 10 power. So y second prime, right, it's going to be negative 1 times, I believe we can do some reduction if possible. I think this guy will be able to reduce here. All right, so I'm pretty much left with negative 1. I'm going to use negative exponents. So I'm going to have 5x to the 4 y to the fifth minus, well, negative and negative becomes plus, so it will be plus, because you're doing negative 5 times this guy here. It's going to be plus 5. And then you have this guy here, x to the fifth and x to the fifth again, so it's going to be x to the 10 power and y to the negative 1 all over y to the 10. So I'm probably going to put all over y to the 10. We're almost there, but we need to reduce this. We need to simplify this nicely. So what I think we will do is I'm going to just probably write that as a fraction. We could have factored this guy here, but let's just write it as a fraction. I could have taken a, yes, I actually can factor. I can factor a 5x to the 4. In here, I'm gonna factor, believe a y to the negative 1. I could factor a y to the negative 1. Yes, I'm gonna factor a y to the negative 1. So if I factor y to the negative 1 power, I'm actually going to have y to the 6 plus 1, okay, and 1 times x to the 5th, so that will be x to the 6th power, so it's just going to be x to the 6th power, okay? So all of this over y to the 10. So here I'm going to have, so this is getting super complicated, so it's going to be y to the second, y double prime is equal to, okay, this guy here is going to go to the bottom here. All right, so I'm going to have negative 5 x to the 4 parentheses y to the 6 plus x to the 6 all over y to the 11. Now that we get this, we're almost over there. We're almost done. However, this could be our full answer, but let's keep in mind what was y to the 6 plus x to the 6. If you look at the original condition, this pretty much the given equation, that's actually 1. So this is 1. So if that's 1, you're pretty much having y double prime, right? The second derivative is going to be negative 5x to the 4 over y to the 11 power. So that's going to be your final answer. Most of the time, whenever you're trying to look for that second derivative, pretty much at the end, you are going to have this equation there, like pretty much from the original. Okay, so just be aware of that. It happens often. Okay, so to find the second derivative, first you need to find the first one and apply the derivative again in each side, and eventually you're gonna have to substitute this y prime that we found here. This y prime here, we substituted for the one we found previously to keep going here. So this is just a hardcore algebra here that you have, especially whenever you're factoring this negative exponent, this y to the negative 1, you're factoring that out. So negative 1 times c plus 6 is going to be the 5 here in the beginning. Negative 1, it's a little bit artificial, harder, but negative 1 plus 6 should be 5. So, but that's what calculus is about. Pretty much you're going to be factoring now negative exponent. You will see that often. Most of the problems that you're working with, you're going to have to factor a negative power. And then from there, you just keep doing your algebra to get your second derivative.